Hey nerds, and welcome back to part 7. Yeah, it's part 7 of the Traffic Lights series. And I promise, maybe this one and one more of those, and then we're done with traffic lights. Forever, I promise, really. So in the last episodes, we went from something that is pretty basic to a thing that has a basic concept of cooperative multitasking. And what we didn't do on all the episodes until here, we didn't look for the memory consumption. I have this open here, and if you look down here, you see the sketch uses about 900 bytes, 976 bytes. Let me write this down up here. So 976 bytes, and it uses 34 bytes of global variables. Yeah, on our Nano over here, this isn't critical. We have 30K left for the rest of the program. We have 2,000 bytes left for local and globals, so we're not in a pickle here. But imagine you want to do this on a smaller CPU. You have something around 2K of CPU, and this could get really cramped in there. So are there ways to use less memory for the same function? You know me, if I ask this question, there probably is a way. What's eating a lot of memory in this thing is the way we store the traffic light phases. We declare a struct over here, and in the struct we have some bowls, and we have a UN16. This sounds like a pretty good way of using space, because one bit, 2 bytes. Well, not exactly. This is an Arduino thing. Every bowl over here, which is 1 bit, is stored in a byte array. So we don't have bits here, we have byte, and double byte. This takes a lot of memory. Can we store this more efficiently? All right, let me draw a byte over here, just for kicks and giggles. In Arduino speech, I can do this, OB, and then I go 1111 and 1111. So this would be, no, I can't type over here. That would be bit 7, and of course over here this would be bit 0. If I now imagine that I go for, say, I put my ample phases in bits into this byte. Just bear with me here. So I go for, this could be my red one, this could be my yellow one, and this could be my green one. And I think I don't want to have it on this byte. I think I want to have it one over there. So now I could store in 1 byte all these information. This would be the states of the LEDs. 1 is on, 0 is off, of course. Now I have 4 bits left. This is 0 to 15. So I can store the length of every traffic light phase in these here. Say, we call it time. So if I store it in seconds and do the multiplication later, I can go from 0 to 15 seconds. Well, that's pretty much what we need, isn't it? All right, let's write this. I'll start with a new array, and this array only contains uint 8 types, so it's bytes. I call it traffic lights. No. Phases binary. Because, give it names you can relate to. Equals, let's go there. And since I know I need my arrays in here, so I can do the same I did over there. I can type OB 1, 2, 3, 4, 1, 2, 3, 4, give it a comma, and copy this a few times. We're going to need this 4 times. So this is a downside to doing this in binary, because human readable goes right out the other window. Without any documentation, you're lost here. So bear with me while I try to type this here. So the first phase would be red, so I need a 1 on the red. This is a yellow, this is green, and I want a red for 2 seconds. Next one I want to have is 1, 1. This is my red-yellow phase, and I want to have this for 1 second. This is utterly wrong what I wrote over here, because of course it's binary. I should write this way. Yeah, looks better. This is a binary 2, this is a binary 1, And now I need a green phase, so this one is lit, and I want to have this lit for 3 seconds, so it's one binary. And going back to yellow, and this should be on for 1 second. So, looks nice. Let's run the compiler and see if I didn't do any errors here. This is just a precaution. And of course, I should have commented this out. And I should have left a semicolon over there. That would be neat. Yeah, and there it worked perfectly. We don't see any size increment here because this structure won't be used. So the compiler simply says, oh, I don't need this. I'll simply leave it out. The human in front of the screen will have a reason because for what he would need this sometimes in the future. Maybe, maybe not. Humans are strange. That's probably what the compiler thinks right now. All right. What I don't need in the future is a struct. And I don't need this construct here because we don't need this anymore. Let's get rid of that and rewrite our traffic light sequence a bit. We don't need to write everything because this part here, so the multitasking thingamajig, still stays pretty much the same. What we will change is this over here. So digital write, this won't come from this array because now we go, let me see, let me copy that. Yeah, you know me, I'm too lazy to write this. And this is the downside of the long variable and function names. There are a lot of possible typos in there. So I'm always a guy who copies these and never tries to type them again. There's no structure in the array left, so I can get rid of those stuff. And now I have to do some bit magic here because I need to get from the... Oh, let me change this here too. And now I have to do some bit magic because I have to get from this thing, this is a byte, to a bit. And Arduino in its whole wisdom gave us a function for that. It's called bit read. Did I do that right? I did do that right. And in bit read, I simply can say, okay, get me the state of a bit at position, whatever, this is position 6. And it will grab the if the bit is set, it will get me 1. If the bit is not set, it will get me 0. So this is exactly what we want. Let me stay lazy here. And of course, this is bit 5 and this is bit 4. Remember, this counts from 0 to 7, so this is okay. All right. I'll need to do something about the delay because the delay now is binary coded over here. So we have to get from binary to something our delay here can use. So let me grab this one. Put it over here. And let me drop this stuff into a variable so it's easier to read. I won't do the multiplication over here, so I can go for U and 8. Type, and let's call it interval. Equals not this, but what we can do here, if I leave it this way, we would have the upper 4 bytes in our interval. We don't want to do that. So we have to do a bit of unending here. Ending, I mean a logical AND, not ending. And since we're in Arduino, I can do the byte thing again. OB1111. This is the part we don't want to keep. And 1111, this is the part we want to keep. Yeah, I could say, of course, I could say 15, or I could say in hex. That's all the same. But I like the binary representation over here, so I want to go for that one. So what we're going to get, in the end over here, will mask out the upper 4 bytes. They will always be 0 in this case. And the lower 4 bytes will be an AND operation of the bytes we set over here and the bytes and these 4 bytes. So we get something like these 4 or these 4 or these 4. You get the drift. I have this in an interval right now, so I need to move this over here because we need the time from that. And since this is in seconds, we need to multiply by 1,000. All right. Moment of truth. Fingers crossed. You always wanted that. You didn't tell me. Why didn't you tell me? Yeah, of course, this is I can't type anymore. And I do it again. Heck. Now it looks better. All right, let's do this again. The most important thing, yeah, it still works. We didn't break the program. That's good news. And on the other hand, look at how our use of static RAM shrinked. Our original program ran with 34 bytes use of global variables, and now we're down to 18. This is nearly half. Nice, I like this. Yeah, and there's a downside, of course. Our program space has grown a bit. Well, sometimes you have to decide what's the lesser evil. You probably will have enough program space while global space runs out real fast. So this is a win. Speaking of wins, you reached the end of the episode. Yay! And as always, I hope you learned something today and you'll stick with the series. I promise you, one more and we're done. And yeah, then comes the tricky stuff. All right, you guys, have a great one. Keep hacking. Bye.